Hey everyone, and welcome back to the BIO110 Recap Podcast. Whether you're tuning in while you're commuting, doing chores, or just relaxing, glad to have you here again.
Yes, welcome back. I hope you're all ready and feeling excited. Bio is the best kind of prep, honestly. But hey, we've got some big updates to kick off today's episode.
Absolutely. First up, let's talk about the upcoming exam. It's scheduled for February 12th, and here's what you need to know. It'll be a multiple choice format, and you'll be taking it right in the lecture room.
And the best part, you can bring your physical notes. I mean, this is all about applying what we've been digging into. So get those notes organized, jot down key concepts, really set yourself up for success. You've got this.
Right, and the format should feel familiar since we've been preparing for this all semester. Also, be sure to come ready to manage your time well. Multiple choice exams can move quickly.
Exactly. And remember, don't just memorize definitions. I want you to think critically. For example, how do these concepts connect back to evolution or natural selection? We'll revisit things like MRSA and those soapberry bugs we keep talking about.
So, just a heads up to stay on top of your review schedule, and don't procrastinate on this one. That'll do it for the preliminaries. Ready to dive into today's content, Dr. Rosario?
Oh, definitely. I can't wait to get into Darwin's key observations and those really fun examples that showcase evolution in action. Let's go.
All right, let's jump right into it. Last time, Dr. Rosario hinted at Darwin's key observations, and today we're exploring those in detail, the very foundation of evolutionary biology. Dr. Rosario, why don't you kick us off with what makes Darwin's insights so groundbreaking?
Oh, absolutely. Darwin was amazing at noticing patterns in nature, and two observations really stood out. First, he saw how within any species, there's always variation, phenotypic variation to be exact. Like no two ladybugs look exactly alike, right? Some have different patterns, different shades. Variation creates the raw material for selection to act on.
Okay, so spotting those differences was the first insight. What was the second?
The second, and this one's big, he noted that most species produce far more offspring than the environment can support. Like, imagine a field filled with spore clouds from tiny plants, releasing thousands of spores, but only a fraction will survive. It's survival of the fittest on display, and that scarcity creates competition. Who gets the food, who survives, who reproduces.
That competition definitely sets the stage, right? Only the best suited individuals pass their traits forward.
Exactly. But here's where it gets fascinating. Evolution via natural selection depends on traits that improve survival and reproduction that are heritable, meaning those advantageous traits are passed down genetically to the next generation, and over time, little by little, populations evolve because of these selective pressures.
And one of your favorite classroom examples of this, I know, is the beetle population, right? Could you recap that for our listeners?
The beetles. Yes, let's say you've got a population of dark and light-colored beetles living in a darker forest. Birds come along and guess which ones they spot first? The lighter-colored beetles. Over time, the darker beetles dominate because they're less visible to predators, and they pass their genes on while the lighter ones disappear. Boom, that's natural selection right there. So tiny changes accumulate into bigger shifts.
All right, listeners, coming off that deep dive into natural selection in action, let's shift gears slightly to explore the pièce de résistance, Darwin's unifying metaphor of the tree of life, and his concept of descent with modification. Dr. Rosario, this framework ties every observation we just discussed into one poetic, powerful whole, doesn't it?
Oh, it totally is, Eric. And Darwin's finches from the Galapagos Islands, classic, right? They're just the perfect gateway into understanding it. So picture this, different islands, each with unique environmental challenges requiring unique feeding strategies. But all of these finches descended from one common ancestor.
That's already amazing to think about. And it's their different beaks that give them an edge for their specific islands, right?
Exactly. Beaks for cracking seeds, slender beaks for digging into cacti. Each one is this marvel of natural selection at work. The environment applies pressure, and traits like these adapt in response over generations. It's descent with modification, common ancestry shaping new adaptations through time.
And it's not just biology in isolation. Isn't there a time element tied to this too? Geological time?
Oh, 100%. Darwin wasn't working alone here. He was absorbing ideas from geologists like Charles Lyell, who emphasized that big shifts can occur through tiny, gradual changes stacking up over immense time spans. Think of erosion carving a canyon. It's the same principle with evolution. Small, incremental genetic shifts stacking up into major species differences. Nature is so cool like that.
It's those timelines that always blow my mind. Billions of years of those gradual shifts shaping everything we see today. But okay, let's mix in a little interaction here. Dr. Rosario, you've got a memory game you like to play with taxonomy, don't you?
Oh yes, I love this one. Okay, listeners, think King Philip came over for garlic shrimp. Eric, can you crack the code?
Let's see. Kingdom, phylum, class, order, family, genus, species. That's the hierarchy of biological classification, right?
Nailed it. And each level from kingdom to species is like a zoom lens, starting broad at the kingdom level and narrowing down to pinpoint an individual species. It's how we categorize and understand the relationships between millions of life forms on Earth. And the deeper you dive, the more those evolutionary connections reveal themselves.
So it's like playing detective across time, piecing together how life forms are connected. Honestly, I think it's a pretty satisfying way to get a sense of who we are in the grand scheme of things.
Absolutely. And when you layer on descent with modification, you see how traits evolve, how they're passed down, and even how new species arise. It's all about continuity and diversity intertwining across evolutionary threads.
All right, we've covered a lot today. Darwin, his observations, finches, taxonomy, and so much more. Any final thoughts before we wrap things up?
Just that this stuff, it's the story of life itself. We're all connected through this incredible, unbelievable process of evolution. Embrace the awe, folks, and maybe start seeing the world through the eyes of a scientist, curious, questioning, and endlessly fascinated.
Love that. And on that note, listeners, we'll leave you here for this week. Great talking as always, Dr. Rosario.
Thanks, Eric, and thanks to everyone listening. Stay curious and keep exploring.
Be sure to share this episode and tune in next week. Until then, take care.